Hello and welcome to my channel SimonRebello hashtag Scholastic Tutorials. Today we are going to solve maths paper for preliminary exams boards 2025. Let's take a glance at the question paper. This is geometry. Okay, now we'll have the solution for the same. Question number 1a. Choose the correct alternative. Answer each of the following questions. Out of the following point, dash lies to the right of the origin on the x-axis. Here are the options: minus 2, 0, 0, 2, 2, 3, 2, 0. The right answer is 2, 0. The solution for that is this is the x-axis, horizontal line, and the vertical line is the y-axis. If a point lies on x-axis, then the y-coordinate is 0. So one among these two, that is in the A, minus 2, 0 or 2, 0 would be the answer. All points to the right of the origin are positive. Therefore, x coordinate is positive. So here in A, minus 2 is the x coordinate, and in D, 2 is the x coordinate. So the right answer is D, 2, 0. Second question. When we see at higher level from horizontal line, angle formed is dashed. A, angle of elevation. B, angle of depression. C, 0. D, straight angle. The right answer is angle of elevation. Here we have a figure, a man standing, and the line which seems to be touching the sky and the earth is called the horizon. So if I keep a sun over here, so this is called the angle of elevation with the horizon. Angle of elevation is equals to angle of inclination. Third, find the side of a cube of volume 1 meter cube. A, 1 centimeter. B, 10 centimeter. C, 100 centimeter. D, 1000 centimeter. Find the side of a cube of volume 1 meter cube. Here we have a solution for that. Volume of a cube is side cube. The volume is supposed to be 1. 1 is equal to L cube. Taking the cube out to the left hand side, we'll get a cube root. Cube root of 1 is that 1 cube, back again cube, and cube root gets striked off. 1 is equal to L. L is equal to 1 meter. Because the volume was given in meters, so the length will be in meters. Now converting meters to centimeters, big to small, we multiply. So 1 meter is equals to 100 centimeters anyways. So 1 into 100 will give me 100 centimeters. If this was 2 meters here, it would be 2 into 100, that would be 200 centimeters. The right answer is C, 100 centimeters. Out of the following, which is a Pythagorean triplet? A, 1, 5, 10. B, 3, 4, 5. C, 2, 2, 2. D, 5, 5, 2. Here we draw a rough figure. The perpendicular sides are 3 and 4, and 5 is the hypotenuse. That's the right answer. All the three sides are equal over here, that is 2 to 2, which is not possible. 5, 5, 2, we got to check. But hypotenuse has to be the greatest side, so two sides are greater, so this is also not possible. Left is 1, 5, 10 and 3, 4, 5. So I'll first take 3, 4, 5 to check. I can take 1, 5 and 10. It should go in this way, left hand side and right hand side. Take the bigger side, that is 5 square is 25, and the two other sides 3 square and 4 square will give me 9 plus 16, that is 25. Left hand side equal to right hand side. Therefore 3, 4, 5 are the Pythagorean triplets. If the square of the bigger number equals to the sum of the square of the other two numbers, or sides you could say, then it represents a right angle triangle, and the three numbers, the three sides are the Pythagorean triplets. Find the height of an equilateral triangle having side 2a. Here we have a figure, equilateral triangle ABC. Side AB is 2a, BC is 2a and CA is 2a. The altitude AD we have to find at the height. Solution: for an equilateral triangle, altitude is √3 upon 2 into side. That is formula. Altitude is known as height. Height is equal to √3 upon 2 into side. √3 upon 2 into BC. √3 upon 2 into 2a. 2 gets striked off. √3 into a, that is √3a units. In case we have to find area, the formula for area is √3 upon 4 into side square. √3 upon 4 into 2a the whole square. When square comes in, it will become 4a square. The 4 and 4 will get cut off. So since I have no space over here, so left over will be √3a square units. Next, find the slope of line if theta is 45 degrees. Here we have a line, slope is theta, which is 45 degrees. Line, that is line segment AB. Slope is symbolized as m. Slope is equal to tan theta. Formula: theta is 45, so tan 45. In the table, we'll see in the trigonometric table, tan 45 is 1. Next, find the volume of sphere of diameter 6 cm. Here we got a figure, volume is question mark, diameter is 6. This is a sphere. For a sphere, volume of sphere is equal to 4 upon 3 pi r cube. 4 upon 3, the value for pi is 22 upon 7. Diameter, radius is diameter upon 2. Diameter is 6. That is given. So 6 upon 2 the whole cube. 4 upon 3 into 22 upon 7 into 6 upon 2 into 6 upon 2 into 6 upon 2. 2 1s are 2 3s are 2 1s are 2 3s are 2 1s are 2 3s are 3 1s are 3 1s are. Left is 4 into 22 into 3 into 3. That will give me 113.14 centimeter cubes. That is for volume. Volume answer will be always in cube, centimeter cube here. Next, if two circles are touching externally, how many common tangents of them can be drawn? In the figure given below, we can see 3 common tangents. I draw 2 circles, and these are the 3 common tangents: line L, line M and line N. So we get in all 3 common tangents. Question 2a, area of sector of a circle of radius 15 centimeters is 30 centimeters square. Find the length of the arc of the sector. Radius is 15 centimeters, area of sector is 30 centimeters square. Now area of sector is equal to dash, 30 is equal to length of arc into 15 upon 2. Length of arc is equal to dash. In fact, it is printed length of arc is equal to 4 centimeters. Let us see how it goes. Very first, try to align the sum. Here we draw a circle AOB. I put x over here and y over here. These are the radius. Radius is 15. Area is 30 centimeters square. Here I take AXB as length. and it can be also the degree. So theta is equals to dash, which is not given. Now for area of sector, that is O dash AXB, the formula is theta upon 360 into pi r square if theta is given. If theta is not given, length is given, then area is half into length into r, that is radius. Solution for a circle, radius is 15 given, area of sector is 30 centimeter square. Area of the sector is what? Half into length into r. Area of sector is 30, which is equal to half into length into radius is 15. Cross multiply, we'll get 30 into 2, 15 will come down here, upon 15 is equal to L. 15 1s are 15 2s are 2 2s are 4, 4 is equal to L, L is equal to 4 centimeter. Length of the arc is 4 centimeter. So length of arc AXB is what? 4 centimeter. Quadrilateral MRPN is a cyclic. Angle R is equal to 5x minus 13 and angle N is equal to 4x plus 4 the whole degree. Find the measure of x. Quadrilateral MRPN is cyclic. Angle R plus angle N is equal to 180. Here we got to write the reason. Now here for below R is given 5x minus 13 plus N is equal to 4x plus 4 equals to 180. 5x minus 13 plus 4x plus 4 after opening the brackets is equal to 180 degrees. Dash minus dash is 180. X is equal to dash. We got to align the sum first in a proper way. First of all, we draw a circle. Align the solution in quadrilateral MRPN. Quadrilateral MRPN is cyclic. Given angle R plus angle N is equal to 180. Below angle R, I'll put 5x minus 13 the whole degree plus 4x plus 4 the whole degree equal to 180 degrees. Open the brackets. 5x minus 13 plus 4x plus 4 is equal to 180 degrees. Getting x together, 5x plus 4x will be 9x. Minus 13 plus 4 will give me minus 9 is equal to 180. 9 is common. X degree minus 1 degree is equal to 180. Getting 9 to the other side in the denominator. Cross multiply. X degree minus 1 degree is 180 upon 9, that is 20 degrees. 9 1s are 9, 2s are 0 is left, so 20. Getting 1 on the right hand side, I'll get x degree is equals to 21 degree. Hence x is equal to 21. Remove the degrees, you get x equals to 21. This is how you align it, keeping the equal to straight in between. And the reason over here, opposite angles of cyclic quadrilateral are supplementary. When you get r plus n equals to 180, opposite angles of cyclic quadrilateral are supplementary. Prove that cos square theta into 1 plus tan square theta is equal to 1. Left hand side, cos square theta into 1 plus tan square theta is equals to cos square theta into dash, cos square theta into dash, which is equal to 1. First of all, we will take the left hand side and right hand side. Cos square theta into 1 plus tan square theta on my left hand side and equal to 1 on my right hand side. 1 plus tan square theta is sec square theta. That's the identity formula. Sec means 1 upon cos, that is 1 up. Now sec square theta means 1 upon cos square theta. Cos square theta will get cut. So 1 into 1 upon 1. 1 into 1 is 1. So my left hand side is 1, which is equal to right hand side. Find the volume of a cone if the radius of its base is 1.5 centimeter and its perpendicular height is 5 centimeter. Here we'll draw a cone. This is the radius here, the perpendicular height and length. Height is 5 and radius is 1.5 centimeters. So volume of cone is equal to 1 upon 3 pi r square h formula. Value for pi is 22 upon 7. Radius is 1.5 the whole square. H is 5. Now when I remove the point out, I'll get 10 in the denominator. So I'll get 1 upon 3 into 22 upon 7 into 15 upon 10 into 15 upon 10 into 5. 3 1s are, 3 5s are. 5 1s are, 5 2s are. 2 1s are, 2 11s are. 2 1s are, 2 11s are here. Okay. So left is 11 into 15 into 11 into 15. That is upon 7 into 2. That will give me 11.79 centimeter cube. If sine theta is equal to 7 upon 25, find the value of cos theta and tan theta. Here is the solution. We will first take a right angle triangle ABC, put theta over here to angle A and 90 minus theta for C. Angle B is 90 degrees. So sine theta is opposite upon hypotenuse, that is BC upon AC, that will give me 7 upon 25. Here we will write. Then I will go for solution in right angle triangle. Sine theta is opposite side upon hypotenuse side, that is BC upon AC, 7 upon 25. That is the trigonometric ratio and which is given over here. Now in right angle triangle we get AB square is what? AC square minus BC square. Taking the square on the right hand side we get a square root. AB is equal to square root of AC square minus BC square, that is 25 square minus 7 square, 625 minus 49, 576, root of 576 is 24 square here. Square and square root gets cut, 24 units. So I'll write here 24. Now since I've got all the three sides, I can find all the trigonometric ratios, that is cos and tan is to be found. So sine theta is opposite upon hypotenuse, cos theta is adjacent upon hypotenuse, tan theta is opposite upon adjacent, cot theta is adjacent upon opposite, sec theta is hypotenuse upon adjacent, and cosec theta is hypotenuse upon opposite. Now sin theta is BC upon AC, cos theta is AB upon AC, and tan theta is BC upon AB. So replace those values over here. That will be 7 up, sin theta is 7 upon 25, cos theta is 24 upon 25, and tan theta is 7 upon 24. Trigonometric ratios. Now we can do this in another method also. Now solution. First of all, I'll take sin square theta plus cos square theta is 1 because sin theta is given. So I'll take the identity formula. Take sin square theta to my right hand side over here. Cos square theta is 1 minus sin square theta. Square will go to the right hand side, it will become a square root here. Cos theta is 1 root of 1 minus sin square theta. Put the value for sin square theta, that is 7 upon 25, the whole square, 1 minus 49 upon 625. Taking LCM, I'll get 625 minus 49, the whole upon 625. 625 minus 49 is 576. Denominator is 625 back again. Square root of 576 is 24. So that's 24 square here, and 625 is 25 square. So taking square as common here, square and square root will get cut. 24 upon 25. Cos theta is 24 upon 25. We should know how to solve. This is the identity formula. Sin square theta plus cos square theta is 1. Now left is tan theta. Because I got sin theta and cos theta, I can find all the remaining trigonometric ratios. Only tan theta is to be found. Tan theta is sin theta upon cos theta, that is 7 upon 25, the whole upon 24 upon 25. Now invert it over here, 7 upon 25 into 25 upon 24. 25 gets cut off, 7 upon 24. So tan theta is 7 upon 24. This is the second method. Find the point on the x-axis which is equidistant from A minus 3, 4 and B 1, minus 4. Here is the solution. Let the required point be P, x, y, equidistant from A and B. Distance PA now will be equal to distance PB. Take the distance formula for PA and distance formula for PB. Put the values: x minus x1 the whole square plus y minus y1 the whole square, and here x minus x2 the whole square plus y minus y2 the whole square, and both are in square root over here. Distance PA is this. Now putting the values over here, the value for A is minus 3, 4 and B is 1, minus 4. So this is x1, y1, x2, y2. Cutting the square root on either side, I'll get now x plus 3 the whole square plus y minus 4 the whole square is equal to x minus 1 the whole square plus y plus 4 the whole square. Before that I had put this in brackets, so minus and minus will give me plus here. and here minus and minus will give me plus. Now taking x plus 3 as whole square, I get x square plus 2 into x into 3, that is a plus b the whole square का formula, and here 3 square, here a minus b the whole square का formula, y square minus 2y into 4 plus 4 square, here I'll get x square minus 2 into x into 1 plus 1 square, here I'll get y square plus 2 into y into 4 plus 4 square. Proceeding, I will open the bracket now. I'll get x square plus 6x plus 9 plus y square minus 8y plus 16 is equal to x square minus 2x plus 1 plus y square plus 8y plus 16. Cutting y square on either side and x square, left will be 6x plus 9 minus 8y plus 16 is equal to minus 2x plus 1 plus 8y plus 16. 6x plus 9 minus 8y equals to minus 2x plus 1 plus 8y. Getting all the terms to the left hand side, I'll get now 8x minus 16y plus 8, taking 8 as common, then taking 8 to the denominator on the right hand side. I'll get now x minus 2y plus 1 equals to 0. Because the point was lying on the x-axis, the y coordinate becomes 0. So x minus 2 into 0 plus 1 equals to 0. Point lies on the x-axis, therefore y coordinate is 0. X minus 0 plus 1, x plus 1, that now equal to 0. X is equal to 0 minus 1, x equal to minus 1. Therefore the point P is x comma y minus 1 comma 0. Y coordinate is 0 and x is minus 1. Next, construct a tangent to a circle with center P and radius 3.5 at any point M on it. Here is the rough figure. Since the point lies on the circle, we will get one tangent. First draw a circle of 3.5, radius 3.5, point M, extend the line M, draw arcs on either side, left, right, take the measurement of the arcs, draw arcs on either side up and down. From either arc, join those arcs, a perpendicular is drawn, that line L having segment AB in between over here. So point M is perpendicular, this is a tangent over here. Next, do sides 7, 24, 25 form a right angle triangle. Give reasons. For a right angle triangle, we just draw a rough figure over here. Not exactly the right angle, taking the bigger side 25 over here. Let us check now. If the square of the greater side equals the sum of the squares of the other two sides, then it represents a right angle triangle. Left hand side will take the greater side, 25 square 625, and the other two is 7 square plus 24 square, that is 49 plus 576 is 625. From 1 and 2, left hand side equal to right hand side. Therefore 7, 24 and 25 represents a right angle triangle, as it satisfies the statement over here. Find the coordinate of the midpoint of the line segment joining the points 22, 20 and 0, 16. Solution by midpoint formula. X is equal to 22 upon 2, x is equal to dash, y is equal to dash, that formula here, y is equal to 36 upon 2, y is equal to dash. The answer for point M is 11, 18 is the midpoint of this line segment. Let us see how it goes. Solution by midpoint theorem, or midpoint formula you could say. X is equal to x1 plus x2, the whole upon 2, formula 22 plus 0, x1 and x2 upon 2, that is 11, y is equal to y1 plus y2 the whole upon 2, 20 plus 16 the whole upon 2, that is 36 upon 2, that is 18. M is x comma y, that is 11 comma 18. M is the midpoint of line segment. We can also put here formula. Next, sine 4 theta minus cos 4 theta equals 1 minus 2 cos square theta. Left hand side, sine square theta the whole square minus cos square theta the whole square, which is equal to bracket into bracket, which is equal to 1 into bracket, which is equal to 1 minus dash, which is equal to 1 minus 2 cos square theta. Let us solve and see how it goes. The very first step we had was sine square theta, or you can write q also, the whole square minus cos square. I'll say theta over here, theta the whole square. Now sine square theta, this whole thing sine square and cos square is just like a plus b and a minus b. Now a square minus b square, a square minus b square. So I will get a plus b into a minus b, that is sine square theta plus cos square theta is 1. Here sine square theta minus cos square theta will be as it is. 1 into sine square theta minus cos square theta is as it is, so 1 will have no value over here. Open the bracket, sine square theta minus cos square theta. Now sine square theta is also known as 1 minus cos square theta according to identity formula, because identity says sine square theta plus cos square theta is 1. So if I keep sine square theta on my left hand side, it will become 1 minus cos square theta. That's here. So when I open the bracket, I'll get now 1 minus cos square theta minus cos square theta, that is 1 minus 2 cos square theta. From 1 into left hand side equals to right hand side. The questions are given this way. We got to solve and try to understand how it comes. Next, draw a circle of radius 3.4 centimeter. Draw chord MN of length 5.7 centimeter in it. Construct tangents of point M and N to the circle. Now this is a rough figure. Tangents have been drawn over here and they meet at external point P. Since the point M is on the circle, we'll get one tangent, and even on point N, which is on the circle, we'll get one tangent. How to construct? First of all, we'll take a circle of radius 3.4. Then we'll take the protector with measure 5.7. Mark it over here. 5.7. Draw the arc. Now extend the radius OM and ON, keeping the compass on M, drawing arcs on either side. Any measure, just nearly about 1 centimeter or more than half, you could say. Take the measure of both the arcs, draw arcs up and down, draw the tangent, repeat the same process at point N, draw arcs on either side, and take the measure of the arcs, draw arcs on up and down, top and bottom, join the arcs, draw the tangent. Since I have no space over here, this point where they meet is a point N, point P. Tangents drawn from external point are congruent, but here the tangents are drawn from the circle, and this is how it has to be constructed. Both are congruent, MP and APN are congruent. Draw a circle with radius 3.4. Draw a chord MN of length 5.7 centimeter in it. Construct tangents of point M and N to the circle. This is a rough diagram. Radius 3.4, chord 5.7. Tangents have been drawn at point M and N. Point M lies on the circle, so we get one tangent, and point N also lies on the circle, so we get one tangent. Where the tangents meet is point P. According to point P, tangents drawn from external point are congruent, so MP and PN are congruent. How to construct? First, we'll draw a circle of radius 3.4. Then we'll take a chord that is taking measure of 5.7. Keep the compass over here. Draw 5.7 arc. Join that and name it as MN. Extend the radius OM and ON. Standing on point M, draw arcs on either sides with the compass. Take the measure of the arcs. Draw arcs up and down, join them. Line L is constructed here now. Repeat the process at point N. Draw arcs on either side, taking the measure of both the arcs. Draw arcs up and down. Draw line M. The point where these tangents meet is point P. Because I have no place, so I have put it this way. And your construction is ready. Sum of the squares of the adjacent sides of a parallelogram is 130 square centimeter and length of one of its diagonal is 14 centimeter. Find the length of the other diagonal. Here is the solution. We will first draw a parallelogram ABCD. Adjacent side BC and CD. Square of them is 130. Diagonal BD is 14, so I put 7 over here because diagonals bisect each other. I've got to find the diagonal AC. Solution in quadrilateral ABCD. Quadrilateral ABCD is a parallelogram. Given AC bisects BD at point O. AC bisects BD at point O. Property of parallelogram, that is diagonals bisect each other. In triangle BCD, this triangle, I can apply Apollonius theorem. CD square plus CB square is what? Twice CO square plus twice DO square. Apollonius theorem. 130, that is CD square plus CB square, is equal to 2 CO square plus 2 DO square. DO is half of BD because diagonals bisect each other. That is half BD, and BD is 14. 2 1s are 2 7s are, so I'll get 7 over here. That is 7 square will be 49. 2 into 49 will be 98. Rest all is same. So 130 minus 98, and I'm bringing 98 to the left hand side, is equal to 2 CO square. That is 32 CO square is equal to CO square, 2 CO square. Getting 2 to the denominator on the left hand side, 32 upon 2 will give me 16. Taking the square out to the left hand side, it will become a square root. Root 16, that is 4 square. Square and square root gets cut. 4 is CO. CO is equal to 4 centimeter. I got CO as 4. Now AC will be double of it. Now AC is 2 times CO. Diagonals bisect each other. That is 2 times 4. That is 8. Statement 3 states that this is 4. So I put the reason over here. And the other diagonal is 8 centimeter.